Yeah, so geothermal power has been used for centuries or millennia, really. It's you know, as you move down from the surface into the ground, the temperature increases, and so if you have an aquifer or some other permeable layer, and you can draw out the water from that aquifer, it'll typically be warmer than the water at the surface. So you can pass that through a heat exchanger and remove the thermal energy from that, and that can provide a source of low-grade heat. So that can be used for you know, agricultural uses or heating buildings and so on. But then there are some systems, particularly in geologically active areas of the world, where there's much hotter permeable reservoirs which contain steam or essentially boiling water at temperatures 250 degrees or higher. And if you can drill into those and draw out the steam, you've then got a very high source of energy because you have all the latent heat of vaporization stored in that steam. And so if you condense that steam or pass it through a turbine and condense it, you can recover a lot of thermal energy. And so there's systems in Italy, in northern Italy, in a place called Larderello. In the northern California, there's an area called the Geysers where they have a lot of geothermal power. Iceland obviously has a lot of geothermal power. And one of the challenges is that as you draw out the fluids or deplete the reservoir of steam, the pressure drops, and so it gets more difficult to keep on producing the thermal energy. And so one of the engineering solutions is to inject water into the system, and as the water migrates into this very hot rock, it'll boil. And so you then get a boiling front as this water migrates into the formation. And understanding what fraction of the water boils as it moves through the rock and what fraction just gets warmed up is a key part of the problem. But there's also a whole series of interesting precipitation phenomena that occur, or mineral phase change phenomena that occur, because the solubility of water to different minerals changes with temperature. And so when you pump water in, which is initially cool and then warms up, its solubility to different minerals changes, and that can lead to reaction fronts moving through the formation. So there's some discussion in the book about some of the dynamics of these reaction fronts.